My name is Angela McClure, and I'm an extension professor and corn and soybean specialist with the University of Tennessee. And my presentation for Mylan No-Till is Soybean Management by Maturity Group. So maturity groups, I think, are an important topic of discussion because they play a really important role in helping stabilize and protect yield in Tennessee. So I'm going to start with just the basics, about what is a maturity group. So the maturity of a soybean is the number of days from planting to 95% brown pod. So this is right before harvest. And soybean breeders develop varieties with different maturity lengths. So varieties that have a similar maturity length are just kind of lumped together in a group called a maturity group. And within the maturity group, there are slight differences in maturity. For example, with a maturity group 4 variety, if you have a 4.1, it's considered an early 4. Maturity group 4.8 would be considered a late 4. When you get about a half a point difference, usually is when you can start seeing some visual or physical differences in maturity within a maturity group. So many years ago, the United States was divided into what are called maturity zones. And so the maturity zone is just an invisible line drawn across a specific latitude in the United States. And within that latitude, there's a specific photoperiod. And breeders developed varieties that had the best fit within that zone. And the idea was that if you planted a recommended maturity group within your zone, you were guaranteed to make a crop by early frost, or by average frost, I would say. So for many years, basically folks planted within the zone. And in Tennessee, it was just a common practice to plant determinate group 5s on just about every acre. And about 20 years ago, soybean breeders and agronomists started recognizing that if you move what would be considered a northern maturity group south of its zone, it actually behaves a little differently with respect to when it flowers and when it matures. And that's actually an advantage in southern climates. So for example, in Tennessee, we brought group 3s and group 4s, and in some cases group 2s to Tennessee. And we found that in our latitude, they flower earlier, they harvest a little bit earlier, we can access indeterminate growth habits, wide flowering windows, and additional genetics. And they have been pretty much, I'd say, a game changer in Tennessee as far as being able to stabilize yield by including some of these what would be considered earlier maturity soybeans. So when a farmer is trying to decide what to plant, I think most of the time, the realization is you don't plant the same variety on every acre. There are reasons for spreading risk by planting different varieties. And the same is said, I think, for maturity groups. They're just kind of a tool that we can use to help offset things, especially negative impacts of things like planting date, heat, drought, some of those things that certainly impact yield. By planting different maturity groups, a producer can actually determine when he wants to harvest a field. He's able to access new or different soybean genetics that kind of step outside of that maturity group. So all of that kind of goes back into, I think, spreading risk. And I think the big thing about planting multiple maturity groups is that some maturity groups have a better fit than others if you're planting late. And the figure on the right, that's just kind of a pie chart of what we plant in Tennessee. And I just kind of put together an estimate as far as maturity group share of acres. And you can see that a group 4 obviously is a really important maturity group for Tennessee, followed by the 5s and the 3s and the group 2s, which are kind of a niche choice for producers that are trying to get an August delivery. So the pieces of the pie, I think, change a little bit depending on, when we plant and the planting conditions that we have from year to year. So these are some estimates as far as the percent of total planted acres for 2019 versus 2020. And you can see in 2019 we had kind of equal amounts of soybeans planted in early and late May and June, which is kind of a little bit more typical, maybe something that we kind of hope for. Not a lot of planting in April. In 2020, and again, this is June of 2020, we're still planting soybeans. This is kind of my best guess of where we're going to be this year. But I think at least half of our acres are going to be late planted. So we have a substantial number of late planted acres. And again, maturity group choice, I think, is going to be critical to doing a little bit better job on yield. So based on, some of the maturity group work that we've done across the years, we see that, choice of maturity group affects how tall the beans are at the end of the year, the number of nodes, pod load to some extent. Planting date basically impacts all of the above, but they also impact and interact significantly with maturity groups with respect to the seed weight, seed moisture at harvest, seed quality, and very particularly seed yield. So not all maturity groups respond to planting dates the same. So in Tennessee, we encourage early planting. We ended up with sometimes we end up with a lot of late planting. So both of these scenarios have their challenges, but planting in April, a couple of things that planting early does for us is that we've got more days in our growing season. So we've just got a longer growing season to maximize yield. And because we're planting in April, we're basically shifting more of that vegetative growth before the summer solstice when we've got more sunlight. And so we're intercepting a lot more light per day, longer growing season, and that kind of helps support the idea that this potentially can give us higher yields. The challenges with early planting is some years we can't do it. It's too cold, it's too wet, got to work around other crops and some other things going on there too. But the payoff, if you can do it, I think is in just maximizing the use of that growing season. So late planting, and this would be June and sometimes July. The challenge is obviously everybody knows it's drier, we got more heat, and we've got a shorter growing season. And so picking the right maturity group to kind of maximize yield in this type of situation is certainly very important. So we've done a lot of work with maturity groups and planting dates, and this is just kind of a list with a little bit of a description about some of the work that we've done over the years. I'm going to mention some of the results from our irrigated and dryland studies. Basically, we try to keep a consistent seeding rate or a consistent row spacing in these studies and just try to get some idea of how the different maturity groups respond to early versus late planting and try to identify maybe ones that seem to have the best fit year in and year out for Tennessee. So one of the things that we discovered with our irrigated work was that the different maturity groups respond differently to late planting, specifically the yield decline. And I think everybody kind of recognizes the later that we plant, we tend to have lower yields. But under irrigation, where we're taking out the rainfall factor with late planting, under dryland conditions, we're supplying water, we still get a difference in how maturity groups respond to late planting. So what we found is that group 3s and 4 varieties have a quadratic or kind of a curved response to later planting, and group 5 varieties have a linear response. So a linear response usually means that it's a steeper decline or the bushels per acre loss, particularly with those later plantings, is going to be higher than something that has a quadratic response. So our irrigated planting date maturity group data are summarized in this table. And this was actually a project that we did as part of a national project, and so we looked at maturity groups that ranged from a 3 all the way to a group 6. And if you look at the chart kind of going from left to right, We were able to summarize this work and estimate yield decline for early versus late planting, and you can see some differences there with the different maturity groups. And then our yield data is not presented as hard yield numbers. This is percent of maximum yield. So basically, we summarized the data across the 2 years, and we found the best, the optimal yield combination, and that would be a group 4 planted in April. And so everything else was compared to that optimal combination with respect to yield. And as you go from, an April planting date to a late or a mid-June planting date, you can see that percentage, the percentage of maximum yield declines the later and later that we plant. But some maturity groups have a slightly higher or more stable number than others within those later planting dates. So when we're planting in April, May, and even early June, if we're adding irrigation, basically all of those, the maturity groups, the 3s, 4s, and 5s, yielded similarly. In other words, they would all be good choices for any of those planting windows. And those are the cells that are highlighted in blue. When we get into June, kind of that mid-June window, we start to see a little bit of a separation between how the fuller season varieties did compared to the shorter season varieties, if you will. So a group 5, I think, is still a great soybean for Tennessee and a good late plant option. But our irrigated data suggests that if you can supply water, a group 3 is actually a better option than a 5 as a kind of that later June type planting window. And so I thought that those results, I think, were kind of interesting and kind of supported, again, that group 3 is maybe a little bit better fit than a 5, with that later planting. The Dryland work that we've done, we are actually still in the process of completing this project. We've got the data this year that will be averaged in with the past 3 years. But I wanted to show some preliminary data from the past 3 years with some Dryland planting date maturity group work. And we've looked at group 2s all the way to 5s. And we planted from late April to about early to mid-June, depending on the year. And our yield data here is also expressed as percentage of maximum yield. And, within a planting date, if the cell is highlighted, it basically just says that those maturity groups performed the same for that planting date. We compared everything again to a group 4, but our maximum yield with this particular data set was a group 4 bean planted in early May. So everything else is compared to that percentage-wise. You can see our late April percentages are very solid. They're very, much closer, I think, to that maximum yield number. The group 5s in particular, I think, we've seen this multiple years do extremely well, planted as a late April type option, giving them the kind of that fuller season there. But we had halfway decent rainfall, I think, in the 3 years that we've done this work. So the 3s actually kind of held their own even as late as that late May planting window. When we get into June, we did see some changes there. The group 4s and 5s under dryland conditions appeared to be more stable at those later planting dates. The 3s and particularly the 2s, I think, fell off there, which kind of supports the idea that under dryland conditions you might want to consider a group 4 or 5 is probably your more stable options if you're planting in June. So what about ultra late planting? I just threw this in there because I think this is one of the years where we might actually have some July planted beans, and it's not an ideal situation for yield. We're typically looking at a low yields situation. We need moisture when we plant, or we need a rain as soon as the beans are planted to get them out of the ground and growing. And the idea is that you're kind of in a race with the clock to try to get yield before frost. Based on some of the work that I've done and some of this older work from USDA at Milan, I think my pick of the litter for an ultra late planted soybean would probably still be a group 4. And I might go with an earlier 4 versus a late 4. We've had fairly good luck with group 3s in some of our work. But again, it's not a high yield situation. You're basically just trying to salvage something and harvest that crop before a frost. So, in my opinion, probably an early 4 might be probably the best pick for an ultralate situation. So I get questions about managing maturity groups occasionally. Is there should I be doing something different with a 3 versus a 4, for example, or a 5? And I went back and looked at some of our data. I'm just going to make a couple of quick comments here, but it looks like, for the most part, management practices aren't necessarily changing depending on the maturity group. So that's probably good news there. Get asked about seeding rates sometimes, and many years ago, and probably still now to some extent, folks kind of look at a group 2 or a group 3 variety as kind of a less or a bean that tends to not branch as much, and so maybe we need to plant more seeds per acre to kind of help make up the difference there. And this was some work that was done a few years ago now, but we've had a few smaller projects where we've looked at a couple of maturity groups, and my take is that we may see a slight yield increase by increasing seeding rate, but a lot of times a substantial increase in seeding rate comes at a cost and is usually not offset by the increase in yield. So my take on it, because we use a lot of seed treatments now on soybeans, it protects stand. There's not really a justification to going with a higher planting rate for a 3, for example, versus a 4 or even a 5. Soybeans do a great job of adjusting their pod load, adjusting their seed size, that type of thing. So seeding rates are probably the least way to manipulate yield, if you will. What about narrow rows? I think my take on it is I think it's always a good idea, if you can, to plant on narrow rows. And some of the older work that we've done where we were specifically looking at maturity groups, I think supports that. Regardless of the maturity group, we can get a response to a narrow row. We are canopying a little bit quicker, we're intercepting more sunlight, we're suppressing weeds. There are lots of good reasons, to plant on narrow rows. This is some work that was done a few years now, but it just kind of illustrates that all maturity groups respond to a narrow row. And I think the thinking initially was that we would see a bigger response with a 3 versus something like a group 5, but we kind of saw the opposite of that. Fuller season maturity groups actually responded as well or even better in some of our work than an earlier maturity bean. So narrow rows, I think, are important and a good practice, not necessarily a reason to do anything different based on maturity group. What about irrigation? And I'm just going to make a couple of comments here. I think sometimes, we think if we plant a shorter maturity bean, we might not have to put as much water out. And that may or may not be the case. Basically, a group 3 soybean compared to something like a group 5 soybean, it's going to bloom quicker. And so it's shifting reproduction earlier. It's shifting, when those pods start to set a little bit earlier. And sometimes, especially if we're planting in April or early May, it means that when reproduction starts, that bean may actually have pretty good soil moisture and we may not need to water. So from that aspect, you might water less with an earlier maturity bean versus a fuller maturity bean. If you're one of those that likes to irrigate the entire reproductive window, you might water a few less days with a 3 versus a 5. You can see here these are just some average numbers of days between different reproductive stages for something that would be considered kind of an early May planted soybean. So you can kind of see between R1 and R6, group 3, there are fewer days there versus a 5. I think most of our irrigation work suggests that that's probably not a good practice to start watering early, but to focus, monitor soil moisture and focus on those later reproductive stages to try to do a good job with watering. So that would be R3 to R6 or even R5 to R6 if it's a year where we're getting a lot of good rainfall early season. So when I looked at average numbers of days between R3 and R6, based on some of our irrigation data, there weren't a lot of differences, right? You're not really adjusting the number of days that you're watering there. Between R5 and R6, and this is seed development, seed fill, there's slight differences. That earlier maturity bean, might hit full seed a little bit quicker than a 4 or a 5, but you're not saving, weeks and weeks of watering by going with an earlier maturity bean. I think the take home is keep an eye on your field, check your growth stages. Hopefully you have a soil moisture sensor in there that's telling you that, when you're running out of water, and shut the water off after you passed R6. That's just kind of a good practice regardless of maturity group. I don't think early maturity beans typically save us a lot as far as watering time. Just a couple of take-home messages. Again, I think cultural practice-wise, or how we grow the beans, I don't think we see a lot of differences in how we do it. But I think our irrigated and our non-irrigated data both support good yields with April planting dates. And that's kind of there's always a caveat there, because some years we can't do it. But if you can plant at least part of the crop in April, I think it's a good practice. Always include a seed treatment, check your soil temperature, check the short-term forecast, and in particularly plant varieties that have good resistance to sudden death and stem canker. And I think that was probably one of our biggest learning lessons in the planting date maturity group work that we've been doing. We had an early group 5, and we had grown it for 2 years. Planted it last year in a different field. Field had a little history of stem canker, and that particular variety we lost anywhere from 30 to 70% of our yield because of the stem canker. So that's a big thing about planting in April. So I think our data points out that in Tennessee, if you want to plant early, whether you're watering or not, you've got good choices. A 3, a 4, or a 5 would all be good choices if you're going to plant early. If you are partial to group 5s, one way to help them yield better is to plant them early, in April in particular. We've seen that in some of our work. So for late planting options, under irrigation, I think our work supports a group 3, maybe over a group 5, and a group 4 is probably the best fit. For dryland conditions, maturity group 4 or 5, both of those will work very well and seem to be stable year in and year out if you're not able to irrigate. So if you have any questions about the information that I presented, here's my contact information. Feel free to call me or email me if you have any questions. I did want to say a special thanks to our Tennessee Soybean Promotion Board, and have been an extremely important to my program, and I think a lot of other programs too. Just wanted to say a shout out to those guys. With that, thank you for listening.